Welcome students to Combining Functions Graphically. And you can see I've got the grid all set up, and I've also listed two functions over here on the side. Now what I'm going to do is I'm going to take these two functions, I'm going to graph them, and then I'm going to show you how we could combine them. And it's a pretty straightforward process actually. So let's start by getting the graph. You can see they're both lines. The first one has a y-intercept at -3. So there we go with -3. And it has a slope of 1. So it means over 1 and up 1. Okay. I'm going to use the line draw feature and attempt to do a decent job of this. Let's see if we can do a decent job. Not too bad. Something like that. Okay, so that's the first one drawn. Now I'm going to go and, I better label this as F. Okay, now I'm going to do the graph here of G. So it has a y-intercept at +1, and it has a slope of -2, which I'll think of as -2 over 1. So it's like going down 2 every time I go 1 to the right. Okay, so let's use the line draw feature and see if I can do a decent job of that. Okay, so something like that. And let's label that. That is function G. Okay, so those are my two graphs. Now what I'm going to do is I'm going to try to combine these two functions, and we can combine them by adding them or subtracting them, multiplying or dividing. I'm going to try, first of all, just a good old addition. And what I'm kind of doing is I'm taking the two functions and saying, hey, why don't we splice them together and treat this as a kind of a new function? You know, is that a possibility? You know, maybe it's function H or something, and it's made up of these two functions. So how do we get an idea what this new function looks like? And the strategy that we're doing today is by doing it graphically. It's really quite easy if you remember what f of x actually is. F of x represents the y's for certain x's. Just like over here, g of x represents certain y values for specific x's that you've plugged into function g. In other words, let's say I pick some points. Why don't I just say, let's see what happens when x is 0 and get a point on function f. So if I go, well, let's see, function f here, if x is 0, function f is down here, it has a value of -3. Okay, so it'd be kind of like saying, if I'm going to add together f of 0 plus g of 0, that's like saying, well, that's just -3 plus, oh, and I got to work out g of 0. So g of 0 is here at +1. Okay, so I'm just going to add these numbers together, and I get a value of -2. So it's like saying our new function, when we plug in 0, we get -2 as a y value. And all I did was I used the y values from f and from g and just added them up because it says add the two functions together. So that means I'm here. Okay. Now, a little bit of a shortage on space here. What I might have to do, maybe I'll just work on the grid here or something. What if I want to take, say, another x value? Let's say we want to figure out one more point. How about when x is 1? Figure out where that is. If we plug that in, we're basically saying f of 1 plus g of 1. So I'm going to go to my lines here and figure out what those are. F of 1 looks to be -2, so that's like -2. And g of 1 looks to be -1. So I think we're getting -3 as the y value. Okay, so that is the point 1 to the right, and we're down at negative 3. All right, you know what this looks like? It looks like a line going this way. Now, they're not always going to turn out to be lines when you combine functions. In fact, most of the time it's probably more complicated than that. This one does turn out to be a line, which makes producing the picture pretty easy. So let's just draw it in there. Something like that. So this is the new combination. So this little guy here, this is our new function. This is f plus g. Yeah, and that's pretty much the technique. That's about all there is to it. You examine the y values of the individual functions, and then you combine them with however you're told to combine them. In this case, I just wanted to add them together and see what I got. And I got this line here. And it's an interesting thing that if you worked out the equation of this line has a y-intercept at negative 2, and it has a slope of negative 1, right? Because we go down 1 and over 1. So that would be negative x. So this function actually looks like this. It's a linear equation with negative x minus 2. Now let me just show you kind of an interesting thing. What if I just took the functions themselves here and I added them together? What if I took f and then I added to it g? Okay, what would I get if I did that? Okay, if I did that, I would have x plus negative 2x, which is negative 1x. And then I'd have negative 3 plus 1, which is negative 2. Oh, gee, that looks very familiar to this. Surprise, surprise. So yeah, no real surprises there. That's how these things work. Now, suppose I wanted to do something else. Suppose, and I'll just clean off the slate here. And let's say I wanted to graphically combine some other functions. So let's just say I had some kind of whimsical function that did some goofy thing like this. Okay? Let's just say that's f of x. Okay? And let's say g of x is some kind of a line, and I'll just slap one down here like that. Let's say that's, whoops, don't want another line. Let's say that's g of x over here. Okay? What if I said, just figure out a few of the following points. When x is 2, please figure out f of x times g of x. Okay, just to show you the strategy we would use. Well, what you would do is you'd go to your graph and you'd say, well, when x is 2, f of x looks like 1.3. It looks like roughly 1.3. And then I have to multiply that by g of x, which, oh gosh, it looks like 0 at an x value of 2. So the y value would be 0. Now what this would be, if I actually wanted to graph this, and I was putting all of these points into a table of values, okay, I could put in there, when x was 2, we came up with 0. Now, I could keep going like this. I could say, well, what about when x is, let's try an easier one. Let's try when x is 0. Okay, when x is 0. Okay, well, what have I got here? Oh, these are both the same y values. Looks like 1.2, I guess is what it looks like. So it looks like 1.2 times 1.2. So that would give me a y value, I think, of 1.44. Okay, so that's another point on my graph. And I would keep going like this, and who knows what I'm going to get. I mean, you know, chances are we could get all kinds of very complicated functions. The only way you could tell is you would do enough of these points, and that would rule out things like, oh, it doesn't look linear, or maybe it looks quadratic, or maybe it's cubic, or maybe it's quartic. Who knows? But we could just keep going like this, and you can see it would be very labor intensive unless you use some computer program or a graphing calculator to combine these functions. But the process is, in essence, you pick your x value and you work out the individual function values or the y values off your graph, and then you just go ahead and multiply them together, and that's the y value for this particular combination. And that's where I'm going to stop for this part of it.